Welcome to the screencast for 4.5. Here's part 2, which covers the cotangent function as well as the cosecant and secant functions. So, the cotangent function is literally the reciprocal of tangent. Since tangent was sine over cosine, no surprise, cotangent is the reciprocal, which is cosine over sine. As I talked about with tangent, tangent was undefined at all points where cosine equals 0 because that was the bottom. Well, here, sine's the bottom, so it'll be undefined any place sine is equal to 0. So let's go back to the unit circle that you learned, and let's label the 4 main quadrantal points. Keep in mind, x comma y corresponds to cosine comma sine. All right, so this first point over here, our y value is 0 and our x is 1. So that's 0. At pi over 2, we have 0 for the x, 1 for the y. At pi, we have negative 1 comma 0. And then at 3 pi over 2, we have 0 comma negative 1. So the places where cosine or sine goes to 0, sine. So sine goes to 0 at pi, 2 pi, 0, which makes sense because here is pi, 2 pi, 0. These are all where the asymptotes are because that is where sine goes to 0. Because keep in mind, cotangent is cosine over sine. And if sine goes to 0, I have some number over 0, and that is undefined. Thus, we have vertical asymptotes. So this one looks similar to tangent. It's just like shifted over and flipped. Anyway, we're going to be using the inequality still, but the bounds are where sine is 0. So sine is equal to 0 at 0 and pi. Cool, so that's what we'll be using. All right, let's do example 3, graphing a cotangent function. So let's locate the vertical asymptotes and sketch the graph of y equals cotangent of 2x. So I'm going to go 0 less than equal to 2x less than equal to pi. Right, so you see it just comes from here. This is my b. I need to get x by itself, divide everywhere by 2. So 0 less than or equal to x less than or equal to pi over 2. So my whole period goes from 0 to 2 pi, so now my period is smaller. And then I already found my vertical asymptotes. It's literally my bounds. So it's going to be when x is equal to, 0 and pi over 2. 0 and pi over 2. Let's go ahead. Let's plot this guy. So here. All right, so what should I pick for my coordinates? Or my axes labels? Well, I want to have my 2 asymptotes, and then I want a middle point, and then I want halves of that. It's similar to the way we've been doing it. So we plot our vertical asymptotes first. Let me see. So between 0 and 2 pi. So I'll have this be my pi over 2. Oh, sorry, over pi over 2. This is my 0. This is going to be pi over 4. Let's see. This will be pi over 8, because that's halfway between 0 and pi over 4. And this is going to be 3 pi over 8. Kind of makes sense, because if we do have pi over 8, 2 pi over 8, it's 1/4, or pi over 4. 3 pi over 8, and then we have 4 pi over 8. That simplifies to pi over 2. Cool. This is why sometimes I'll label my graphs like this, just so you can see I have equal spacing. Just side note, you have to have equal spacing when you're graphing. Always do that. All right, step 1. Let me draw my vertical asymptotes. So 0 and pi over 2. Okay, step 1 done. Step 2, I need to do my midpoint. So let me find what cotangent will be of pi over 4. So y equals cotangent of 2x. So if I want, what the heck, what? Cotangent. Ooh, okay. Cotangent of 2x. So cotangent of 2 times pi over 4, because I'm doing my halfway point, that's just going to be cotangent of pi over 2. So think about what are our sine and cosine values. So we have cosine over sine is cotangent. So at pi over 2, at 90 degrees, regular circle. So at 90 degrees right here, we have 0, 1. So cosine 0, sine 1, which means cotangent is 0 at pi over 4. Hey, it's similar to the tangent function. Our very midpoint is going to be 0. Let's go ahead to our other 2 points. So I found my mid. So lastly, we're going to find the halfway between the vertical asymptote and the mid. It may or may not surprise you. I feel like you will know what these numbers will be. So cotangent of pi over 8. Don't forget to multiply by 2 because here's that stupid 2 in my function. So this will be cotangent of pi over 4. Well, pi over 4, sine and cosine are the exact same values. Exact same values. So this means it's going to be square root 2 over 2 divided by square root 2 over 2, which is 1. So at pi over 8, we have a value of 1. And then if we do 3 pi over 8, so cotangent, let's see, 2 times 3 pi over 8, that's going to be 6 pi over 8, cotangent of 6 pi over 8. Let's see, that's going to be 3 pi over 4. Cotangent of 3 pi over 4, that's going to be, let's see, 3 pi over 4 right here. Notice that I have a negative x value and a positive y value at 3 pi over 4. How did I know that? Well, going all the way around is 1 pi, so I just want to go 3/4 the way. So this means that, let's see, my cosine is going to be negative. Cosine, because cosine's x. So negative square root of 2 over 2 over square root of 2 over 2. That's just going to be negative 1. So I have negative 1 value right here. Negative 1. Negative 1. So now we just have to connect the dots. So connect it this way. Connect it this way. It looks just like a tangent function. Flipped and moved over to the side. Makes sense because cotangent is just a reciprocal function. Let's keep going. So cotangent and secant. So, I'm sorry, cosecant and secant. Cosecant and secant are, well, they're also the reciprocal. It may not surprise you to learn that cosecant is 1 over sine of x. And so whenever sine is equal to 0, it's going to have asymptotes. Asymptote, 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 asymptote. Say that 5 times. So we have asymptotes whenever sine is equal to 0. Same way, secant is just a reciprocal cosine, so it's going to have asymptotes whenever cosine is equal to 0. So let's see, cosine is equal to 0 at 90 degrees and 270, so it's pi over 2, 3 pi over 2, anytime cosine is equal to 0. So notice that there's the dotted cosine and sine functions. It's showing you over here, cosine and sine are on there. So cosecant has a minima, where sine has a maxima. Because right here, sine is equal to 1. Sine is equal to 1. And so if you choose the reciprocal of 1, I mean, it's still going to be 1. So that's the point where they meet. All it's saying is cosecant is, well, it's basically going to be mirroring sine whenever they're touching, wherever they go to meet. It has minima where sine has maxima. So right here is the maximum for sine. Well, that's going to be the minima because that's the very bottom point. Versus the maxima where sine has a minima. So here's the bottom part. Sine is the minimum of negative 1. Well, that's going to be the maximum. That's going to be the top part of the parabola for cosecant. Similar with secant and cosine. Cool. So where one has a max, the other has a min. Where one has a max, the other has a min. Okay, let's go. So the period of both secant and cosecant functions are 2 pi over b. And vertical asymptotes can be found by using the following equations, basically where the sine and cosine are 0. So here we have the graph of 2 sine of 2x to help us graph. So let's go ahead, let's use this graph of 2 sine 2x to plot the 2 cosecant 2x. So unfortunately here, if I would use the inequality, I wouldn't get the right answer because there's going to be 2 sets of asymptotes for every 1 period of sine. So if I would plot this as a period of sine, so even though sine only undergoes 1 period of 2 pi, you can see there's going to be more than 2 asymptotes. There's actually going to be 3, because I need to make sure I draw the upper cosecant and the lower cosecant. So that's what this is saying right here, is if we solve b of x plus c equals negative pi and b of x plus c equals 0, we can find the asymptotes. So let's go ahead, let's do that. So I have 2x equals negative pi, so divide by 2, so we have x is going to equal negative pi over 2 as an asymptote. 2x is equal to 0, divide by 2, we have an asymptote at 0, and then there's going to be one more. There's going to be one at b of x plus c equals pi. So you can literally see it's going to be every pi over 2, but let's just double check anyway. B of x plus c equals actually regular pi. So 2x equals pi, divide by 2, x equals pi over 2. So right here I have 0 as an asymptote. So at 0, there's an asymptote, which makes sense, because look, sine, our sine function was 0 there. Negative pi over 2, I have an asymptote. At pi over 2, I have an asymptote. Notice every pi over 2, I have an asymptote here as well. Okay, sorry, those look ugly. So how do I justify this? How do I say this? Well, when x equals 0, pi over 2, pi. I'm just going to do the positive ones for now. But you can see from the upper graph right here, you can see there's multiple, like you have multiple times of the same function. All right. So I know where my asymptotes are. What's the period? Well, the period is going to be pi. It takes pi to do a whole 1. Because we have to have the upper, and we have to have the lower, so we'll have the upper and the lower, so it's going to take pi to do 1. Another way to figure this out is 2 pi over b, so 2 pi over, my b was 2. Once again, I want to show you both ways to do it. So you can tell by looking at the graph that it takes pi, sine takes pi to do 1 period, so cosecant will take pi to do 1 period. So, period's pi. Let's go ahead and plot this. So this one, honestly, so I know at pi over 4, I'm going to have a value of 1 because the reciprocal of 2, the reciprocal is going to be the same thing. So here, and then you just plot it both ways. All right. Try the next one, and then I will go over it. So here's the solution. I'll give you about 5 seconds to do this one, and then pause. First hint I'll give you is to draw negative cosine of 2x, so it's negative, so it's going to be flipped over the x-axis, and you need this so you can draw the secant. So I found the total period by knowing that this is the reciprocal of cosine, so I'll have the exact same period. Found the period for cosine, right, from 0 to pi, so that means it's going to be the same length between, it'll be the same length for the total period as pi. Don't get confused, because the distance between 2 asymptotes here is only pi over 2, but we need the whole thing, because notice we have a happy face and a sad face. We have both halves of the secant function. So period's pi, and then the asymptotes, well, normally, where is cosine equal to 0? Cosine's equal to 0 at 90 degrees and 270, so at pi and 3 over 2, and 3 pi over 2. So I went ahead, solved here for my asymptotes. So at pi over 4 and 3 pi over 4, so once I draw those on my graph, I was like, well, you know what? I also, since I drew my cosine function, I know I have a asymptote here. I know I'm going to have an asymptote here. I mean, I could literally draw this one in. So how do I actually plot this? Well, I know it's going to have the same value as my cosine function at its peak right here, or at its valley at the very bottom. So you have that point, and then you just have to draw your arrows going up or down on whatever side you're on, because we don't know any other values. If you remember, we only learned 5 values of cosine, and that's the max, 0, min, 0, max. Well, here's a 0, here's a 0, here's the max, so you don't know any other points, so you just kind of have to, like, you know, draw it that way. That's the end of this screencast. Let me know if you have questions.